Welcome dear student and Jai Swaminarayan. Today in this video we will discuss the answer of the questions given in the textbook of the chapter number 4 structure of the atom, right? So up till now we have discussed the chapter number 4 is all completed, right? Now in this video we will discuss about the answer of the questions given in the textbook. So let us start with the first question given on the page number 47. On the page number 47, first question is given, what are canal rays, right? So dear student, we know that the canal rays are the positively charged radiation that can pass through the perforated cathode plates. When the positive charge uh, particles are passed through the perforated cathode ray plates, right? The canal rays are emitted, right? So here the canal rays are nothing but a positively charged radiations that can pass through the perforated cathode plates. These rays consist of the positively charged particles and later it known as a proton, right? So canal rays are nothing but a positively charged particles known as the proton. Question number 2. If an atom contains one electron and one proton, will it carry any charge or not? Dear student, we know that the electron is a negatively charged particle and proton is a positively charged particle. Now here, the atom contains the one electron and the one proton, right? Electron is a negatively charged particle, whereas the proton is a positively charged particle. And the magnitude of both the electron and the proton, the charge on the electron and the charge on the proton are same in a magnitude, right? But the charge on the electron is negative and the charge on the proton is positive, right? So that we can say that an atom containing one electron and one proton, one electron has the negative charge and the same charge is on the one proton, that is the positive, will not carry any charge. Thus we can say that the electron will be a neutral atom, right? Thus the atom is a neutral, electrically neutral, according to the J.J. Thomson. J.J. Thomson's model, right? The atom consists the equal amount of the positive and the negative charge. So we can say that the atom is a electrically neutral, right? So here the atom consists of one electron and one proton. Will it carry any charge? It will not carry any charge and the atom will be a electrically neutral, right? So understand the answer of this both the question. Now next set of question is given on the page number 49, right? First question on the page number 49. On the basis of the Thomson's model of an atom, explain how the atom is neutral as a whole, right? So as per the J.J. Thomson's model of atom consists of both the negative and positive charge, which are equal in the numbers and magnitude. So they are balance each other. As a result of this, the atom as a whole is electrically neutral. So in the previous question also we were discussed, right? So atom consists the equal amount of the positive and the negative charge and equal magnitude, right? So it will balance each other and as a result of this the atom is a electrically neutral, right? Understand? Second question, on the basis of the Rutherford's model of an atom, which subatomic particle is present in the nucleus of the atom? So on the basis of the Rutherford's model of an atom, Rutherford stated that all the positive charge is concentrated at the center and the central portion, small central region is called the nucleus. So on the basis of the Rutherford's model of an atom, the positive charge is present in the nucleus. So protons, we are considering the proton as a positive charge. So protons are present in the nucleus of the atom, right? So understand the answer of this both the question. Now question number 3. Draw a sketch of the Bohr's model of an atom with the three cells, right? So according to the Bohr's model, whole the positive charge is concentrated at the central region. This region is called the nucleus. So first draw the nucleus and write the positive charge on the nucleus, and after that, in that the electrons are revolving in a different cell like a K cell, L cell, M cell, N cell, or we can say that the first orbit, second orbit, third orbit, fourth orbit. So write the circular orbit, first orbit, that is a K cell, n equal to 1, second orbit, that is the L cell, that n equal to 2, and that third orbit, that is the M cell, n equal to 4. You can write a fourth orbit also. You can draw a fourth orbit, N cell, n equal to 4. But here our question is limited up to the 3 cell, right? Understand? Question number 4 on the page number 49. What do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than a gold, right? What do you think? Is it possible to carry the experiment of the scattering of the alpha particle is carried out by a other metal other than the gold instead of the gold, right? So answer is that if the alpha particle scattering experiment is carried out using a foil of any metal as thin as gold foil used by the Rutherford, there will be a no change in the observation, right? So there is a no change in the observation when we take a foil of a other metal instead of the gold, right? But since the other metal are not so malleable, so that such a thin foil is difficult to obtain, but we cannot obtain the thin foil of the other metal compared to the gold metal, right? So it is difficult to obtain a thin sheet of the thin foil of the other metal compared to the gold metal. So if we use a thick foil, now if we use a thick foil of the other metal, then the more alpha particles would bounce back, and no idea about the location of the positive mass in the atom would be available with the such a certain region, right? So we cannot get if we consider the thick foil, right? So first reason is that the other metals are not so malleable, so it is difficult to obtain a thin foil such as a gold foil. But instead of this, if we take a thick foil, the more alpha particles are bounced back, and we cannot get the exact location of the positive charge on the atom, positive mass of the atom with the certainty as we get in the golden foil, right? So understand answer of this all the four questions on the page number 49. Now next set of the question is also given in the same page, right? Question number 1. Name the three subatomic particles of an atom. The three subatomic particles of the atoms are protons, electrons and neutrons. Here dear student, we know that the proton and neutrons are lies in the nucleus, right, and the electrons are revolving around the nucleus in the specific orbit, right. So the three subatomic particles, or we can say that the three fundamental particles of the atoms are a proton, neutron and electron. Protons are a positively charged particle, electrons are a negatively charged particle, and neutrons has a no charge, right? Proton and neutrons are together in the nucleus called the nucleons also, right? Next question is, helium atom has an atomic mass 4 AMU and 2 protons in its nucleus. How many neutrons does it have? So dear student, how we calculate the number of neutrons? We know that the atomic mass of the helium is 4 and 2 protons are in the nucleus, right? So how we can calculate the number of neutrons? Number of neutrons is calculated by number of neutrons is equal to atomic mass minus number of protons, right? So here the atomic mass of the helium is a 4, right, and the atomic number of the helium is a 2, that means it has a 2 proton, right. So 4 minus 2 we get the 2 neutron, right. So the number of neutrons in the helium atom is a 2. Similarly, you can calculate the number of proton, number of electron, number of neutron of the any elements, right. So see the previous video how we can calculate the number of protons, number of neutrons and the number of electrons. See the previous video of the same chapter, atomic mass and the atomic number, right. Next set of the question is given on the page number 50. Write the distribution of the electron in the carbon and the sodium atom, right. So electron distribution, for electron distribution we must have to know how many number of the electrons are present in the atom, right. So here we need to write the electron distribution of in a carbon atom and in a sodium atom. So first of all we require to know how many number of the electrons are present in the carbon atom and in the sodium atom, right. So here how we can know the number of electron? The number of electrons present in the atom can know with the help of the atomic number. Atomic number gives the total number of protons in the atom, and the number of protons is equal to the number of electrons. So here the atomic number of the carbon is 6. So we can say that the total number of electrons in the carbon atom is a 6. So the distribution of the electron in the carbon atom is given by in the first orbit, or we can say that KL, the maximum capacity of the first orbit is a 2 electron. So first orbit or K cell there are 2 electrons, second orbit or L cell there are 4 electrons, right. So distribution of the electron is like a 2, 4, 8, 18, right, 2 raised to power n, right, 2n square. If n is equal to 1, we take a 2, we get a 2 electrons in the first orbit. If you take the n equal to 2, we get a 4, 2 into 2 square, right, we get the 8 electron. So in the second orbit the maximum capacity is a 8 electron, right, but out of these 6 electrons, 2 electrons are in a first orbit and 4 electrons are in a second orbit. So we can write the distribution of the electron in the carbon atom is 2, 4. For 2 electrons in the first orbit and 4 electrons in the second orbit, right. Similarly, the atomic number of the sodium is 11, right. So how we can distribute the electrons? In the first orbit 2 electron, in the second orbit 8 electron, and in the third orbit 1 electron. So the electron distribution of the sodium atom is a 2, 8, 1, right. In the first orbit 2 electron, or we can say that the K cell, in a K cell 2 electron, in a L cell 8 electron, and in a M cell 1 electron. So this way we can distribute the electrons of the first 18 elements. See the video number 4 for the distribution of the electron, how the electrons are distributed in a different element. So you have to remember the distribution of the electron of the first 18 elements, right. So this given in the textbook also, right. Second question in the page number, on the page number 50 is, if the K and L cell of an atom are full, then what will be the total number of electrons in the atom, right. So maximum capacity of the K cell is a 2 and the maximum capacity of the L cell is a second orbit is a 8. So here the K cell and L cell of an atom are full. So number of electrons in the K cell is 2 and the number of electrons in the L cell is 8. So the total number of the electrons in the atoms are 2 plus 8, we get a 10. So there will be 10 electrons in the atom. So understand? Now next set of the question is given on the page number 52, right? How will you find the valency of atom? How will you find the valency of the chlorine, sulfur and magnesium? And how will you find the valency of any atom, right? So what do you mean by the valency? The bind capacity of an atom to lose or to gain the electron from the outermost orbit is called the valency of an atom, right? So if the number of electrons in the outermost cell of an atom, an element, is less than or equal to 4, then the valency of the element is equal to the number of electrons in the outermost cell. Now first point is that, remember that if the number of electrons in the outermost orbit is 4 or less than 4, the valency of an element is the number of electrons in the outermost cell. But on the other hand, if the number of electrons in the outermost cell of an atom is greater than 4, then the valency of the element is determined by subtracting the number of electrons in the outermost cell from the 8, right? So if the number of electrons in the outermost cell is greater than 4, how we can find the valency? The valency we can find by subtracting the electrons in the outermost orbit from 8, right? For example, if we find the valency of the chlorine, right? So first we need to find the how many number of the electrons in the outermost orbit, and for that we require the distribution of the electron in the atom, right? So first we find the valency of the chlorine. So chlorine, for the chlorine, the atomic number of the chlorine is a 17, right? So how we can distribute the electrons in the different orbit in a chlorine atom? So distribution of the electron in the chlorine atom: in the first orbit 2 electron, in the second orbit 8 electron, and in the third orbit 7 electron, right? Now here, how we can find the valency? There are two rules. If the number of electrons in the outermost cell is 4 or less than 4, the valency is the number of electrons in the outermost cell. But if the number of electrons in the outermost cell is greater than 4, the valency we can obtain by subtracting the number of electron in a outermost orbit cell from 8. So here the 7 electrons are in the outermost orbit for the chlorine atom. So the valency of the chlorine atom is obtained by subtracting 7 from the 8. So 8 minus 7, it is equal to 1, right? Second, similarly, how we can find the valency of the sulfur? We know the atomic number. The atomic number of the sulfur is the 16. So the electron distribution in the sulfur is in the outer first cell 2 electron, in the second cell 8 electron, in the third cell 6 electron. So here in the outermost cell of the atom there are 6 electron, which is greater than 4. So we obtain the valency of the sulfur is subtracting 6 from 8. So 8 minus 6, we get the valency 2, right? Similarly, third point is that magnesium. How you can find the valency of magnesium? The atomic number of the magnesium is a 12. The distribution of the electron in the magnesium is first orbit 2 electron, second orbit 8 electron, and in the third orbit 2 electron is there. So here in the outermost orbit there are 2 electrons in the outermost orbit, and this is less than 4. So the valency of the magnesium is a 2, and it is equal to the number of electrons in the outermost cell, right? Understand? So now second question is on the page number 2 is a first question. If the number of electrons in an atom is 8 and the number of protons is also 8, then what is the atomic number of the atom and what is the charge on the atom? Here the number of protons is 8 and the number of electron is also 8, right? So here the atomic number of the atom is equal to the number of protons. So we can say that here the number of proton is 8, then we can say that the atomic number of the atom is 8, right? 8 proton and 8 electron are there. So both the proton and electrons are equal. So charge on the electron and the charge on the proton are equal and opposite. Since the number of proton and the electrons are same, there will be a charge on the atom is 0, right? because the same number of proton and the same number of electrons are there, the charge on the atom is 0, right? Understand? Second question is that with the help of the table 4.1, a table is given to you in the textbook, table number 4.1. Find out the mass of the oxygen and the sulfur. So we need to find the mass of the oxygen atom and the sulfur atom. To calculate the mass, we require the number of protons and the number of neutrons, right? So mass number of the oxygen is equal to the number of protons plus number of neutrons. So in the oxygen, 8 protons are there and 8 neutrons are there. So the mass or number of the oxygen is 8 plus 8, 16. Similarly, mass number of the sulfur is equal to the number of protons plus number of neutrons. So the number of protons in the sulfur atom is 16. Number of neutrons in the sulfur atom is also 16. So the mass number of the sulfur is 16 plus 16. We get a 32. Right? Understand both the question? Now, next set of the question is given on the page number 53. And last set of the question is given in the page number 53. Question number 1. For the symbol capital H, capital D and capital T, tabulate 3 subatomic particles found in each of them. S for hydrogen or hydronium, D for deuterium and T for tritium, right? We need to find the subatomic particles, number of protons, neutrons and electrons. It is easy to find from the atomic number and the mass number. So here H for the hydronium or hydrogen, or we can say that the protonium, right? H. So in the protonium, one proton is there and one electron is there. There is no neutron in the protonium, right? So one proton and one electron. In the deuterium, right, one proton, one electron and one neutron is there, right? And in the tritium, one proton, one electron and the two neutron is there. So see the previous video of this chapter, isotopes and the isobar. So in the isotopes and the isobar, we were discussed about the hydrogen atom, protonium, deuterium and tritium atom, and the number of protons, neutrons and electrons in the hydrogen, deuterium and tritium, right? Now next question is, write the electronic configuration of any one pair of the isotopes and the isobar. So isotopes which has the same atomic number but the different atomic mass are called the isotopes, and isobars are the same atomic mass but different atomic number. So we need to write the electronics configuration of the one pair of the isotopes. So for that we take the carbon C612 and carbon C614 are the isotopes. Here the atomic number of the carbon is 6 same, but the atomic mass is a different. Have a same electronics configuration as 2, 4, right? So in the 12 electronics configuration, so here the both the isotopes, the number of electrons are same, number of protons are same, but the number of neutrons are different, right? So isotopes have a same electronics configuration. So here in the carbon C614 and carbon C612, 6 electrons are there, and that electronics configuration in the first orbit 2 electron and in the second orbit 4 electrons are there, right? Understand? But isobar, in the isobar atomic mass are same, mass number are same, but the atomic number is a different. So they have a different electronics configuration. For example, select the one pair of the isobar Ne, neon 1022 and neon 1122, right, are the isobar. Here the mass number is 22 but atomic number is a different. So here in the isobar the atomic number is a different, so they have a different electrons, right? So they have a different electronics configuration. So in the Ne 1022, 10 electrons are there, so we can write the electronic configuration in the first orbit 2 electron and in the second orbit 8 electron. In the Ne 1122, 11 electrons are there, right? So we write the electron configuration 2, 8 and 1. In the first orbit 2 electron, second orbit 8 electron, and in the third orbit 1 electron, right? So isotopes having the same number of the electron, so they have a same electronics configuration, but the isobar have a different atomic number, so they have a different electronics configuration, right? So dear student, understand all the questions, answer of all the questions given in the textbook. So in the next video, we will discuss the answer of the exercise of this chapter. So keep watching my video.